Advanced Math, Set 91, Geometric Progressions. So in previous lessons we've done problems involving progressions that look like this, where you have -10, -5, 0, 5, 10, and those are your arithmetic progressions. And the reason why they're arithmetic is because you're adding the same number every time. And we call that the common difference. So -10 plus 5, -5 plus 5, and so on. Now we call -10 the first term, and then the -5 is the first term plus the difference, and then 0 is the first term plus 2 times the difference, and then the first term plus 3 times the difference until we get to the nth term. And so the nth term is going to be the first term plus n minus 1 times the distance. That was just a quick review. So now we're going to be talking about geometric progression. And geometric progression is the same as arithmetic progressions, except that we multiply by the same number every time. Okay, so you multiply by the same number every time. That same number in this time is called the common ratio. Remember, in arithmetic progressions it's the common difference. Here it's the common ratio. So for example, we can start a progression with 8 and then multiply by 2 and then multiply by 2 again and multiply by 2 again. So we get 8, 16, 32, 64. So 8 is the first term, and so on. 8 times 2 is the second term, third term, and so on. We can also write this as 8 times 2 to the first power, 8 times 2 to the second power, and 8 times 2 to the third power. So when we get to n, we're going to multiply by 2 n times, and actually we're multiplying by 2 n minus 1 times. So this should say n minus 1, actually, n minus 1 times. So here's an example of a geometric progression. So we have 8, then 8 times -2, 8 times -2 times -2, and so on. So 8 times -2 is -16, times -2 is 32, times -2 is -64, times -2 is 128. So we have our first, second, third, and fourth terms. So to figure out our nth term, it's going to be the first term times the common ratio, and then to the n minus 1 power. So if the common ratio is a negative number, the terms in the sequence are going to alternate in sign. And now, just like in arithmetic progressions, we have what is called, in arithmetic progressions, it's called geometric means, or arithmetic means, and in geometric progressions, they're called geometric means, which are the numbers that are between the first and last number. Now, the difference between geometric means are between the first and last term of the sequence, but not necessarily on the number line. You can see that our first number is 8 and our last number is 128, but the negative numbers don't lie between 8 and 128 on a number line, so they just lie in between in the sequence. Okay, so let's start with an example. Find the fifth term in a geometric sequence whose first term is -2 and whose common ratio is -3. So we'll start with our first term, and then our second term is going to be the first term, -2 times -3, and we'll just keep going until we get to the fifth term. So we're multiplying by an additional -3 each time. So for the fifth term, it's going to be -2 times -3 times -3 times -3 times -3. So it's going to be -2 times 3 to the -3 to the fourth power, which is 81. So -2 times 81 is -162. So our first term, remember, just to clarify, the first term is a to the 1, second term is a to the 1 raised to the common ratio, or a to the 1 times the common ratio, then a to the 1 times the common ratio squared, a to 1 common ratio cubed, and then finally the nth term is your initial term times the ratio raised to the n minus 1 power, where a to the 1 is your first term, r is your common ratio, and n is your nth term. Okay, find 3 geometric means between 4 and 64. So we write 4 and we write 64, and we know that there are going to be 3 geometric means between them. So 4 is your a to the 1, it's your first term. Your second term is going to be a to the 1 times r, then times r squared, r cubed, and r to the 4th. We know a to the 1 is 4, so 4r to the 4th is equal to 64. Divide by 4, and we know that the 4th root of 16 is 2, but it's not only 2, because 2 times 2 times 2 times 2 is 16, but also negative 2. Negative 2 times negative 2 times negative 2 times negative 2 will also give you 16. So, if we're multiplying by positive 2, we get 4, 8, 16, 32, 64. If we are multiplying by negative 2, we get 4, negative 8, 16, negative 32, and 64. So we have 2 different sets of geometric means, 8, 16, 32, and negative 8, 16, and negative 32. Okay, find 2 geometric means between 2 and 1/4. So again, we draw dashed lines in between. We know that there will be 2 numbers in between 2 and 1/4. We write out a to the 1 is your first term, a to the 1 times your common ratio, then your common ratio squared, and then a to the 1 times common ratio cubed. We know a to the 1 is our first term, which is 2, so 2 times r cubed is going to be equal to 1/4. Divide both sides by 2, we get r to the 3rd is 1/8. Take the cube root of both sides and we find that r is equal to 1/2. Now in this case it's not negative 1/2 because negative 1/2 times negative 1/2 times negative 1/2 would be negative 1/8. So it's just 1/2. So if we take 2, multiply it by 1/2, we get 1. Multiply that by 1/2, we get 1/2. Multiply that by 1/2, we get 1/4. So our geometric means are 1 and 1/2. Find 3 geometric means between negative 16 and negative 1. So negative 16, 3 geometric means, and negative 1. Our a sub 1 is negative 16. When we multiply by the common ratio, then the common ratio squared, then the common ratio cubed, then the common ratio to the 4th power. So a times r to the 4th is equal to negative 1. We know a is negative 16. So we know a times r to the 4th is equal to negative 1. A is negative 16, excuse me. Divide by both sides. Divide by negative 16. So we get 1/16 equals r to the 4th. So take the 4th root of both sides. R is equal plus or minus 1/2. So if r is equal plus or minus 1/2, first we can multiply by 1/2. So times 1/2, we get negative 16, negative 8, negative 4, negative 2, and negative 1. If we multiply by negative 1/2, we get negative 16, positive 8, negative 4, positive 2, negative 1. Our geometric means are the numbers in between negative 8, negative 4, negative 2, and positive 8, negative 4, positive 2.